Lesson 5 of Chapter 3 of Probability and Statistics. Our topic today is z-scores. Your essential outcome is that you will be able to determine the z-score of an observation. So, what z-scores are? We know that all normal distributions have standard deviations, and those tell us different percentages of the data. And so, what we actually can do is we can actually turn all normal distributions so that they are the same if we measure in units of standard deviations and the mean. And so we change these to all be in the form of z-scores. Alright, and so what a z-score means is just it's how far away from the mean things are. And so it just standardizes our data. And so the mean for every standard normal curve then becomes 0, and the standard deviation is 1 for every curve. Alright, and so the z is called the z-score. It tells you how many standard deviations away from the mean an observation is. So for example, if you have a mean of 5 and a standard deviation of 2, what is the z-score if you have an observation of 6? So your z-score, the formula is z equals x minus x bar, and x bar is the mean, divided by Sx, which is your standard deviation. So x is the data point, so that's your observation of 6, so you get 6 minus your mean of 5 divided by 2. So 6 minus 5 is 1, you get 1 divided by 2, that gives you 0.5. So your standard deviation then is 0.5. So, SAT versus ACT. When you apply for colleges, some colleges require the ACT, some of them require the SAT, and so we're going to compare some SAT and ACT scores. So here I have two students. I have Jacob, who got a 16 on the ACT, and Emily, who got a 670 on the SAT. We need to decide who has the higher score. And so we use that formula, that x minus x bar over Sx, to determine who has the higher score. So Jacob's score is 16, so we got 16 minus, he took the ACT, and the mean is 20.8. Alright. 20.8, and we divide it by the standard deviation. For Emily, we do the same thing. Her score was a 670. We do 670 minus 1026 divided by 209. So now let's actually calculate these and see what we get. So for Jacob, he has a standard deviation of -1. And for Emily, she's going to have a standard deviation of -1.70. So now we think about these. Okay, who has the higher score? We want the one that's going to be the highest up. And so if we think about these, okay, well, initially I just automatically think, well, this one's a bigger number, but hang on, we're dealing in negatives. And remember, the bigger the absolute value is for a negative, the smaller it actually is. So this score, Jacob actually has the higher score. And so we can actually work backwards as well. Like if someone had a 2.6 z-score in the ACT, what score did they receive? Well, remember in our formula, it was z equals all of this stuff. So we can, if we use that formula again, we can plug in the information that we know about ACTs. Well, if they had a z-score of 2.6, we put that in for z. We don't know their score, so we leave that as an x, but we know the mean of ACT scores is 20.8. And we know the standard deviation is 4.8. So now we can solve this. Multiply both sides by 4.8. 4.8. 2.6 times 4.8 is 12.48. 12.48 equals x minus 20.8. So we add 20.8 to both sides, add 20.8. 12.48 plus 20.8 gives us a 33.28 for their ACT score. Alright, so what I'd like you to do now is, here are some questions about a statistics class and a biology class and their means and standard deviations of their tests. So for each student, you're going to find the z-score. So for all 4 of these students, find their z-score on each test, and then determine on which test the student had a better score. So pause the video now and do that. right, here you can look at my work. Student 1, their standard deviations for stats was 1.43. For biology, 0.77. I said that they had a better score in stats. For student 2, they got a negative 0.43 standard deviation for stats and a negative 0.77 standard deviation for biology. They did better in stats. For student number 3, they had a 2.14 standard deviation in stats and a 1.54 standard deviation in biology. They did better in stats. And student number 4, they got the mean in each class. So their standard deviations for both of them were 0, and so in both classes they did average. Alright, so working backwards. Here we have some information. We have the z-score of 0 corresponds to 160 pounds for 15-year-old males, and a z-score of 1 corresponds to 170. So using this information right here, we can find the mean and the standard deviation without doing any calculating. Let's think about it. Okay, when the mean, what is the standard deviation of the mean? Well, standard deviation is how far it is from 0, or how far it is from the mean. So if the standard deviation is 0, that's the mean. So we have the z-score of 0, so our standard deviation is 0, which means that this must be our mean. Now if we look at, okay, a z-score of 1 corresponds to 170 pounds. Remember, the one standard deviation, however far that is going to give us the standard deviation. So that from 160 to 170 is 1 standard deviation, so the standard deviation is 10 pounds. And our mean was 160 pounds. That is the end of Lesson 5 of Chapter 3 of Probability and Statistics. Write your summary and your questions. Your essential outcome today was that you'll be able to determine the z-score of an observation.